Hello class. So in this question here, we are going to be recording, or we're going to be calculating the acceleration and the tension force acting on mass 1 in this system. Mass 1 is 2.5 kilograms, and I forgot to put mass 2 in there. Mass 2 is equal to 3.00 kilograms. Okay, when we are looking for this, the first thing we're going to do is we're going to have to define what is the positive, what is the negative direction for each of the masses. So for mass 1, since it's smaller, we're going to assume that it's going to go up, and mass 2 is going to go down. So if mass 2 is going down in that direction, plus is going to be down, and negative is going to be up for mass 2. For mass 1, since it's going up, positive or plus is going to be the up, and negative is going to be the down direction for mass 1. So when we write the FNAT, first I guess we can draw the free body diagrams for mass 1 and for mass 2. So this is for mass 1 and for mass 2. For mass 1, up is going to be the force of tension, 1, and downward is going to be Fg1. For force for mass 2, Ft2 is going to be up, and Fg2 is going to be down. If you're looking for the net force for the whole system, we can say F net, which is the total mass times the acceleration. This is going to be equal to Fg2. Those are the only forces that act on the whole system. Fg2 is positive since it's moving towards the positive in there. See, Fg2 is downward. Fg2 is downward, which is towards the positive side. Fg1 is gonna be down also, of course, but for mass 1, down is negative. So we're going to do that minus Fg1, which is the same as M2G minus M1G. So rewriting this, again we're looking for the acceleration, so acceleration equals M2G, acceleration of gravity, minus M1G, then again acceleration of gravity, divided by the total masses, is capital M, or M1 plus M2. This would give us 2 point, sorry, not 2 point, it would be 3.00 kilograms times 9.8 meters per second squared minus 2.50 kilograms times 9.8 meters per second squared, all divided by 2.50 kilograms plus 3.00 kilograms. The whole thing, if you put it in the calculator, we will get we end up with 0.891 rounded to the 3 significant figures, 0.9090909, and so that would just round off to this number. Now think about this. So acceleration on mass 1 is going against the grain. You can say, you would say here for mass 1 is accelerating upward at that acceleration 0.891 meters per second squared, or you can also say negative 0.891 meters per second squared if you wish, because we're talking about here acting on mass 1. I like to use words. It's foolproof way of writing the answer. So let's look at the tension now. To find the tension, so we're looking for Ft1. That's going to be our unknown. So to do that, we need to do the free body or look at the free body diagram for mass 1. For mass 1, F net 1 is equal to Ft1. That's a positive force because it is up towards the positive for mass 1, and Fg1 is negative because it's going down, and again mass 1 is going upwards, so that would be the negative part. So let's write this with all the formulas that we know. So F net is always mass times acceleration, and as for mass 1 equals Ft1, which is unknown, minus m1g. Rewrite this formula. We end up with we're looking for just Ft1. So Ft1 is equal to mass. So Ft1 is equal to m1a plus m1g. Okay, that's the F net plus the Fg. Putting the numbers in here, we have 2.5 kilograms multiplied by 0.891 plus 2.5 kilograms multiplied by 9.8 meters per second squared. I guess here we need to write that as well. Meters per second squared. You put this in your calculator and you will end up with 26.7. And this is in newtons. Ft1, so Ft1 is up. For mass 1, up is positive, but you can also write up or positive 26.7. That's it.